using the partial quotient method. This is lesson 9, so we're going to look at dividing whole numbers. Today's goal, I can use partial quotients method to find a quotient of two whole numbers when the quotient is a whole number. So make sure you have today's date, your I can, and page number set, and you are ready to move on. Okay, so we're going to use some base 10 diagrams to calculate quotient. So we're just going to take a look at this real quick. So Lana used these base 10 diagrams to represent 372 divided by 3. So this was her diagram, breaking it up into 3 equal groups. Where did these little extra small ones come from? Because we only had 2, right? Yeah, we took one of the, what she did was she took one of the 10s and broke it into its individual ones, so that way it could be broken up into the other parts. That's why it only has 6 10s, because one of those groups of 10s was left over when she put 3 into it. Because when you divide that 7 by 3, you get 3 whole groups of 2 10s, but then you got one extra one. Well, there's another place value smaller, so it got broken up into the smaller pieces. And that's how she got the 124, okay? Which is, kind of what we're looking at here, is the breaking up of those parts and continuing to use that as you go through to divide through. So we're going to use some partial quotients to divide out and calculate some quotients here. All right, so in this is a method that's a little bit different than what Elena did. Remember, Elena did where took and used base 10 blocks to divide it up. Andre did something similar in that didn't just do like a long division, but instead calculated by looking at parts of it, doing what would be more of a partial quotients and dividing in. Okay, so started off here and 3, and really only focused in on that 600 part here. So 3 would go into 600 200 times, or you could think of it as 3 times 200 gave you 600, subtract out, and you had 57 left over. Then the next step was to see how many times 3 would go into 57. Well, it goes in 10 times. Fairly easy, at least, right? So, because again, all we're doing in this method is focusing in on the largest place value digit. So yeah, it really is 3 times 19, as you can see here separated, but really just focusing in on that one part. So that would be 10, gives you 2 left over. And then what you do next is you've got, 27 left over. 3 times 9 gets you that 27. And then all you have to do to find the quotient then is to add these separate partial quotients together to make your total of 219. So it's just a method to help you spread out the parts to make it, a little bit simpler as far as focusing on the pieces as you go through. So back on Elena's diagram, she had 3 physical groups of 200s, using it that way. On Andre's, what do we do to find the same method, or to find the same value? Yeah, we used 600, and then we had just 200, right? So we were looking at the number as opposed to base 10 blocks. Same thing with the 30, and when they're solving out the same things to solve through, comes up the same. Now, this is the one we showed with Elena earlier, and it's not the same as what Andre has. But Andre's using basically the same system, except that his is spread out and with just digits as opposed to using base 10 blocks. All right, let's find the quotient. So find the quotient of 1,332 divided by 9. And you can use either the base 10 model to draw base 10 groups, or you can use how Andre did it. Okay, so if you had done it something like what Elena did, what you're going to do is you're going to break these up into 9 equal groups. Okay, so first we need to take that 1,000. We can't break 1,000 into 9 equal groups, but we can break up 13 groups of 100 into equal groups, right? So you end up with magic 9 of those. Now you've got 400 left over, right? Well, those 400s have to get broken down into tens. So now we have 43 tens, right? Because if we take the 9 out of there, we have 43. So now magic again. So that gave us four groups of 10 in each one. Okay. So we originally had 13 groups of 100. We had 4 left over, which gave us 43 tens. We just did all the complete groups of 10s that we could take out, which we used 36 because we put 4 in each. And then we still have, what, 7 tens left over, right? What happens to that 7 tens? Yeah, now it puts with those ones, and now we have 72 ones, which gives us what? Yeah, gives us what? 8 in each one, right? So we end up with an answer of 148 as the final answer here. Now, of course, that's one way to do it, but you also could instead have done kind of the method that Andre used. So 9 can't go into the 1, it can go into 13. It can go in one time, that's 100. So then 100 times 9, 900. Okay, 9 can't go into the 4, but it can go into 43. How many times can it go into 43? 4 times, right? But this is 43 tens, so this is 40 here. We get the 360. Subtract out. And then, obviously the 8. So then we get 148 because I subtract out that 72 there, and poof. It's really just a preference thing. This is going to lead you more closely to the using long division, what would some people call the regular method of division. But it really is whichever one that you want to choose to use. All right, let's do just 2 of these. Okay, we'll do C and B. Okay. All right, so I'm going to use the partial quotients on both of these. So you should have yours answered by now. Okay, 7 can't go into the 6. It can go into the 66. Can't go 10 times. Let's see, 9 times. So it would be 90. That'd give me 630 here, right? Subtract, I get 35. 7 goes into 35 5 times. And, oops, hang on a second here. Subtract that out and you get 0. So then the answer ends up being here, 95. This is not too much different either, right? Again, I'm going to use the partial quotient method. So 432 goes into there. So 16 can go into there. Let's see. 3 times would be 48. 2 times would be 32. So I'm going to go 20. So that leaves 320. And let's see. We end up with a 2, we get a 1, we get a 1. How many times is this going to go in? Well, think about it. Well, 6 times what is going to get you a 2? 2, yeah, that would be 32. That's not going to be nearly enough, though, is it? What else? Yeah, 7, right? 7 times 6 is 42. Carry the 4 plus the 7 gets you 11. And voila, answer is 27 on that one. Okay. So basically, division, just like we've said before with the division we've talked about, division is splitting a value into equal size other groups. Okay. And we're talking about the value of one of those complete groups. When we were doing fractional pieces, we got something larger at the end for a quotient because we were talking about pieces broken up in a different way. Okay. If you look at 456 divided by 4, you can think of it like this, right? As partial quotients, 4 goes into that 400 one time, right? So one group of 100. Then the 4 would go into, so that leaves us with 100. Subtract out, you're still left with 56. 4 goes into that 5 one time, right? So that's 40. So 56 minus 40 gives you 16. And then it's how much do you add to that 16, or what do you have to multiply that 4 by to make 16? Yeah, 4. Put those together, you still got the 114. It's just looking at those pieces so that when you're looking at the whole thing, it doesn't become overwhelming. It's talking about looking at those pieces to help give you the advantage of using what you know with the smaller pieces, especially if, sometimes those division pieces get to be a little bit much for you to figure out. And if you think about it, using the base 10 one, so we looked at the partial quotients before. I'm going to do this backwards. But the partial quotients, we had the 100. I've got more room on this page. 10 and the 4 coming together. If we talk about this as the base 10 method, you've got 4 groups of 100. Then you've got a group of 10 for each one. And then you've got one left over 10, which you put with the ones. Now you've got 16 ones, and that's how you end up with the 114. So they do have some similarities as far as how they break them up and look at the different pieces. It's just that one deals with mostly just thinking about the digits and the pieces, whereas the other one is more kind of almost a physical model where you actually are seeing each of the parts. Partial quotients advantage can be that, you can break it down and it doesn't take as much room to work out. Advantage of the base 10 can be more that, if you really need to break down and see those pieces more, if you're not really comfortable, especially with your multiples up through knowing your times tables, for example, the more of those the simpler and the easier these other pieces are. Whereas using those base 10 diagrams, can help you out with those if you're still having some struggle with that. It's really just about your flexible thinking on each. And we are done. Thanks for watching.